Hi, I want to go over the Introduction to Pythagorean Theorem notes and examples. We completed this together in class in the Google Meet, but if you showed up late, had to leave early, missed the meet altogether for whatever reason, I want to make sure you get the same information everybody else did. We had a lot of really warm and fuzzy feelings about this lesson today because all the hard work you've been doing, all the confusing stuff you've been doing on tasks 1 through 5 so far comes together, and all of a sudden today will start to click. So let's get in and take a look at what we have. It's going to be super important to take really good notes on this. You can take them within the Desmos activity or on paper. Some people actually do better on paper because then you don't have to toggle through a bunch of tabs or go in and find it, but it's up to you. Here's what we have. In task 5, we learned about something called the Pythagorean theorem. Pythagorean theorem involves only right triangles. On this picture, you can see I have a right triangle. It's got a right angle and it's got 3 sides. Now, the right angle is always marked with a little tiny square. Right angles are super special, or right triangles are super special triangles because they get certain names on the different sides. A right triangle is made up of 2 legs. Those legs we normally refer to as sides A and B. And if you think about our human anatomy, we stand on our legs. Our legs support our body. Well, the legs of a right triangle support the right angle. The third side of a right triangle is called the hypotenuse. The hypotenuse is super special because it only applies on a right triangle and it never touches the right angle. The right angle, if you notice, has this corner that sticks out in the middle of the triangle. In my head, that right angle, this corner looks like it's pointing to the hypotenuse. Hypotenuse is always, 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 always side C. The legs are sides A and B. Something to keep in mind. So let's go in and actually see how this works. When you get to slides 3, 4, and 5, you're going to be asked to just drag some dots. I want you to label the sides. Me, because the hypotenuse is the easiest one to find, it's the first one I pick. The hypotenuse, I look at where the right angle is pointing, goes there. Now, the other 2 sides, this one says A, which is the short leg on this triangle, so I'm going to put it on the short side. B, long side, I did it right. It gives me a little message. I get to pat myself on the back and go ahead and try it again for slide 4 and slide 5. So go do that. Come back when you're done. And you've got that little warm and fuzzy message of well done. Here's where the notes begin. And here's how this works in math. All that work we were doing with drawing the squares was actually work preparing us to learn the Pythagorean theorem and how it works. What the Pythagorean theorem says, if I have a right triangle, the area of side A, and pardon my super sloppiness, now it's really not gonna, we're gonna pretend that's a square. The area of side A, when added to the area of side B, gives us the area of side C. When I know 2 of those pieces of information, I can find the third. So here's how it works. Oops. To find the area of square A, I take that side length and I square it, or I multiply it by itself. Okay. To find the area of side B, I take that side length, multiply itself, or write it as B squared. Now, when I take those 2 areas and I add them up, that gives me the area of C. No matter what, you don't even have to worry about. And notice, I didn't even have to draw all the lines inside the boxes. I just find these 2 areas, add them up, and I get the area of C. Now, keep in mind, normally you're going to be asked to find a side length. This sum of these 2 areas gives you an area. To get down to side length, you take the square root of that. Okay, so here's how it works in the examples on the next slides. If you need to, pause, copy this down in your slide, and then head over on slide 7. Slide 7, we've got a right triangle. The right triangle is labeled with the legs of lengths 3 and 4, and we don't know C. So we have to find the missing side length. So just like I did before, this 3, I need to find the area. If the side length is 3, to find the area, remember, I'm going to do 3 squared, or 3 times 3. That gives me 9. I'm going to do the same thing for this side length. I'm a visual person. For those of you that don't have me as your teacher, I'm a very visual person. Sometimes numbers get a little overwhelming for me, and for some reason, making the pictures makes it a little less scary. That's why I'm drawing the pictures. But to find the area from this side length, again, 4 times 4, that gives me an area of 16. Now, I have to find the area of C. To do that, I take the 9, take the 16, add them up to get 25. All right? Here's the great thing. When you think you're done with this activity, as soon as you type a number in and you hit submit, it tells you if you're right or wrong. I'm not done. I told me my answer was wrong. The reason I'm not done is 25 is an area. 9's an area. 16 is an area. I need to get down to the side length. Remember, 3 plus 4 doesn't equal 5, or 3 plus 4 doesn't equal 5. I need to square root this. So when I take the square root of 25, another beautiful thing about this, I can open the keypad, hit the square root button, type in the number 25. This time when I submit, the square root of 25 is 5. It tells me I'm correct. So you're going to take that thinking and you're going to apply it to slides 8 and 9. It'll tell you if you're correct. If you're not correct, come back, double check that you followed the same process. Double check that you added correctly. When you're done with those, if you're still a little bit confused, over here on slide 10, there's an additional video you can watch. It's a math antics video that'll explain it a little in a different way, give you some more visuals. But there's your notes. Hang on to this. You might want to bookmark this unit to come back to it as you work through the rest. Good luck. We'll see you in class.